Recently, floodwaters ravaged the streets of Kerala in India, Venice in Italy, Mexico, China, Japan, Indonesia, Malaysia, and many parts of the world. Tidal waves swept away the cities, streets, and human population. Climate change is the cause of many disasters in the nature. When temperature rise and ice melts, more water flows to the seas from glaciers. Things that normally happen in geologic time are happening during the span of a human lifetime. It's like watching the Statue of Liberty melt. Scientists who assess the planet's health see indisputable evidence that Earth has been getting warmer, in some cases rapidly. Most believe that human activity, in particular the burning of fossil fuels and the resulting buildup of greenhouse gases in the atmosphere, have influenced this warming trend. In the past decade, scientists have documented record high average annual surface temperature and have been observing other signs of change all over the planet in the distribution of ice and in the salinity levels and temperatures of the ocean. New crocodile species found hiding in plain sight. This glacier used to be closed for Fagre declares as we crest a steep section. His glasses fogged from exertion. He is only half joking. A trail side sign notes that since 901, Spare Glacier has shrunk from more than 800 acres to 300 acres. Everywhere on Earth, ice is changing. The famed snows of Kilimanjaro have melted more than 80% since 1912. Glaciers in the Galwal Himalaya in India are threatening so fast that researchers believe that most central and eastern Himalayan glaciers could virtually disappear by 2035. Arctic sea ice has thinned significantly over the past half century and its extent has declined by about 10% in the past 30 years. NASA's repeated laser altimeter readings show the edge of Greenland ice sheets shrinking. Spring freshwater ice breakup in the northern hemisphere now occurs 9 days earlier than it did 150 years ago, and autumn freeze up 10 days later. Thawing permafrost has caused the ground to subside more than 15 feet (4.6 meters) in parts of Alaska. From the Arctic to Peru, from Switzerland to the equatorial glaciers of Manjaya in Indonesia, massive ice fields, monstrous glacier, and sea ice are disappearing fast. When temperatures rise and ice melts, more water flows to the seas from glaciers and ice caps, and ocean water warms and expands in volume. This combination of effects has played the major role in rising average global sea level between 4 and 8 inches in the past. Scientists point out that sea levels have risen and fallen substantially over Earth's 4.6 billion year history, but the recent rate of global sea level rise has departed from the average rate of the past 2 to 3,000 years and is rising more rapidly, about 1/10 of an inch a year. A contribution of acceleration of that trend has the potential to cause striking changes in the world's coastlines. In southern Louisiana, coasts are literally sinking by about 3 feet a century, a process called subsidence. A sinking coastline and the rising ocean combine to yield powerful effects. It's like taking the global sea level rise problem and moving it along at fast forward. Rising sea level, sinking land, eroding coasts, and temperamental storms are a fact of life for
Kuro, even relatively small storm surges in the past 2 decades have overwhelmed the system of dikes, levees, and pump stations, and he manages upgraded in the 1990s to forestall the Gulf of Mexico's relentless grip. I probably ordered more evacuations than any other person in the country. The current trend is consequential not only in coastal Louisiana but around the world. In its 2001 report that sea level will rise anywhere between 4 and 35 inches, the end of the century, the high end of that projection, nearly 3 feet a meter, would be an unmitigated disaster. Surveying his world from the relatively lofty vantage point of a 12-foot high earthen berm, I don't think anybody down here looks at the sea level rise problem and puts their heads in the sand. That's because soon there may not be much sand left. Rising sea level is not the only change Earth oceans are undergoing. The 10-year-long World Ocean Circulation Experiment launched in 1990 has helped researchers to better understand what is now called the ocean conveyor belt. Oceans, in effect, mimic some functions of the human circulatory system, just as arteries carry oxygenated blood from the heart to the extremities and veins return blood to the replenished with the oxygen. Oceans provide life-sustaining circulation to the planet, propelled mainly by prevailing winds and differences in the water density, which changes with the temperatures and salinity of the seawater. Ocean currents are critical in cooling, warming, watering the planet's terrestrial surfaces and in transferring heat from the equator to the poles. The engine running the conveyor belt is the density-driven thermo-haline circulation. Thermo for heat and haline for salt. Warm salty water flows from the tropical Atlantic north toward the pole in surface currents like the Gulf. Never before have so many humans lived so close to the coast. More than 100 million people worldwide live within 3 feet a meter of mean sea level, vulnerable to sea level rise. A small country in South Pacific has already begun formulating evacuation plans. Megacities where human populations have concentrated near coastal plains are river delta. Shanghai, Bangkok, Jakarta, Tokyo, New York are at risk. The projected economic and humanitarian impacts on low-lying, densely populated and desperately poor countries like Bangladesh are potentially catastrophic. The scenarios are distributing even in wealthy countries like Netherlands, with nearly half its landmass already at the below sea level. Rising sea level produces a cascade of effects. Bruce Douglas, a coastal researcher at Florida International University, calculates that every inch 2 centimeter of sea level rise could result in 8 feet, 2.4 meters, of horizontal retreat of sandy beach shoreline due to erosion. Furthermore, when salt water intrudes into fresh water, it threatens sources of drinking water and makes raising crops problematic. In the Nile Delta, where many of Egypt's crops are cultivated, widespread erosion and saltwater intrusion will be disastrous since the country contains little rather other arable land. In some places, marvels of human engineering worsen effects. Local projects like that might not do much good in the very long run through depending on the course of change elsewhere. Even without such major event, the IPCC projected this saline water losses heat the air as it is carried to the far reaches of the North Atlantic. The coolness and the high salinity together make the water more dense, and it sinks deep into the ocean. Surface water moves in to replace it. The deep, cold water flows into the South Atlantic, Indian and Pacific Oceans, eventually mixing again with warm waters, risking back to the surface. Changes in water temperatures and salinity, depending on how drastic they are, might have considerable effects on the ocean's conveyor belt. Ocean temperatures are rising in all ocean bases and as much deeper depth than previously thought, say scientists at the National Oceanic and Atmospheric Administration, NOAA. Arguably, the largest oceanic charge ever measured in the era of modern instruments. Much change in oceanic temperature and salinity could disrupt the North Atlantic thermohaline circulation enough to slow down or possibly halt the conveyor belt, causing drastic climate changes in time spans as short as a decade. Oceans are important sinks, absorption centers for carbon dioxide, and take up about a third of human generated carbon dioxide. Data from the Bermuda monitoring programs show that CO2 levels at the ocean surfaces are rising at about the same rate as atmospheric CO2. But it is in the deeper levels where Bates has observed even greater change. In the waters between 820 and 1,476 feet, that is 250 and 450 meters deep, carbon dioxide levels are rising at nearly twice the rate as it is in the surface water. It's not a belief system, it's an observable scientific fact. Bates says, and it shouldn't be doing that unless something fundamental has changed in this part of the ocean. While scientists like Bates monitor changes in the oceans, others evaluate CO2 levels in the atmosphere. In West Manio Island, a lighthouse attendant opens a large silver suitcase that looks like something out of a James Bond movie. Telescopes out of an attached 15-foot 4.5 meter rod and flips a switch, activating a computer that controls servo motors, valves and stopcocks. 2.5 liter flask in the suitcase filled with ambient air. In Northern Africa, an Algerian monk, Asikam, does the same around the world. Collectors like these are monitored. Peter Tons, a Dutch-born atmospheric scientist with NOAA Climate Monitoring and Diagnostic Laboratory, oversees a slew of sensitive instruments that test the air in the flask of its chemical composition. On this way, TANS helps assess the state of the world's atmosphere. By all accounts, it has changed significantly in the past 150 years. Working through the various labs filled with cylinders and standardized gas mixtures, absolute manometers and gas chromatographs, TANS offers up a short history of atmospheric monitoring. In the late 1950s, a researcher named Charles Keeling began measuring carbon dioxide in the atmosphere above Hawaii's 30,679 foot, that is 4,169 meter Mauna Loa. The first thing that caught Keeling's eye was how carbon dioxide level rose and fell seasonally. That made sense since during spring and summer, plants take in carbon dioxide during photosynthesis and produce oxygen in the atmosphere. In the fall and winter, when plants decay, they release greater quantities of carbon dioxide through respiration and decay. Killing's vacillating seasonal curve became famous as a visual representation of the Earth's breathing. Something else about the way the Earth was spreading attracted Killing's attention. He watched as CO2 level not only fluctuated essentially and seasonally, but also rose year after year. Carbon dioxide level has climbed from about 315 parts per million from Killing's first readings in 1958 to more than 375 ppm today. A primary source for this rise is indisputable. Humans produce burning of carbon-laden fossil fuels for their factories, homes and cars.
Antarctica is melting fast. A NASA study that used cutting-edge technique to look through satellite data has provided the sharpest focus yet on how fast the Antarctic ice sheets are melting. Researchers found that in 2015, Antarctica lost roughly 1,929 gigatons of ice, 89% of which was from the western part of the continent. The study confirms that the West Antarctic ice sheets are melting more rapidly than those in the east, with glacier flows increasing in response to warming oceans. The area has also experienced major iceberg calving incidents in recent years, which renders the larger region of ice left behind more prone to melting. If the entire western Antarctic ice sheet were to melt, previous studies estimate it could cause a 3-meter rise in global sea levels. Scientists say loss of the ice sheet may be inevitable, unless the world can manage to decarbonize in the near future and keep emissions low. Are you hot? You will be.
Thought climate change predictions were scary? Well, they just got a whole lot scarier. The possible effects of climate change are far worse and could come far sooner than we previously thought. So says James Hansen, a leading climate change researcher who was among the first to warn the public about the serious effects of the buildup of carbon dioxide. The former director of NASA's Institute for Space Studies, along with 18 other leading climate scientists, published a paper this week predicting rapid sea level rises could happen within decades. The team of researchers' primary claim that as the ice sheets in Greenland and Antarctica melt, a layer of cold fresh water will build up over the ocean, trapping warmer, salty ocean water with which it doesn't easily mix underneath the surface, and thereby leading to a feedback loop that causes ice shelves to melt even more rapidly, effectively slowing down and possibly shutting down ocean circulation. An idea apparently not too dissimilar from the premise of the 2004 disaster movie The Day After Tomorrow. The scientists believe that this ice melting will cool polar regions of the globe and warm areas around the equator, causing stark temperature variances that could make superstorms, such as Hurricane Sandy, which struck the U.S. East Coast with devastating effect in 2012, far more frequent. To argue their case, the researchers controversially claim that storms during the warm Eemian period 120,000 years ago were powerful enough to lift massive boulders 1,000 tons in size from the bottom of the ocean and hurl them ashore. Hansen and his team believe a multi-meter sea level rise could occur before the end of the century and envelop all of the planet's coastal cities. Despite the dire predictions, Hansen, in an accompanying video, explained that there may possibly still be an opportunity to reverse this worrying trend, saying, quote, "I doubt that we have passed the point of no return, but frankly, we're not certain of that."
Global warming is killing our oceans. A new study predicts that within 15 to 20 years, human-caused deoxygenation will be felt across the world's oceans. With climate change warming seawaters, oxygen levels in the world's oceans are beginning to drop. Surface water with higher temperatures absorb less oxygen. Such surface water is also more buoyant, so oxygen is less likely to make it into deeper water. The resulting conditions are dangerous to marine ecosystems which depend on oxygen for survival. With the threat already underway, changes in the southern Indian Ocean and parts of the Pacific and Atlantic will be felt as early as 2030. Oceans in eastern Africa, Australia, and Southeast Asia, however, won't feel the impact until the next century. Worsening the effects of deoxygenation is an increase in carbon dioxide, causing oceans to be more acidic and less habitable. Researchers say carbon emissions must be reduced if we want to slow the oxygen loss, but monitoring and understanding where the oxygen levels are dipping and how it's impacting our waters is also key.
Bears becoming vegetarian because of global warming. Are you hot? Looks like global warming is getting so unbearable that grizzly bears in Alaska are now going vegetarian. According to a new study, grizzly bears on Kodiak Island changed their diets due to climate change and started eating berries instead of salmon. Normally, researchers would see grizzlies eating large amounts of sockeye salmon from streams in preparation for the winter. In the summers of 2014 and 2015, the bears were no longer seen hunting for salmon. The bears were found in the hills eating elderberries. Warmer temperatures were causing the berries to ripen earlier. This meant that salmon and berries were available at the same time. Elderberries contain less protein compared to salmon and require less energy to digest, leading to faster weight gain for bears. The change in diet was also found to be affecting the bear's natural habitat because fewer fish carcasses in the forests meant less nutrients being absorbed into the soil. Climate change has already caused islands to vanish. A new study led by University of Queensland researchers say that changes in global climate and the subsequent sea level rise has already led to the loss of multiple Pacific islands. A team of Australian scientists say that Isabel, one of the main islands of the Solomon Archipelago, has already lost 5 of its reef islands. Another 6 islands on Isabel have declined in area by more than 20% between 1947 and 2014. Meanwhile, residents of the island of Nuatambu have been forced to relocate to the nearby main island of Choiseul because of flooding. Of the dozens of homes that once stood on Nuatambu, at least 11 have already been swept away by the rising waters. While the global average rate of sea level rise has been 3.2 millimeters per year since 1993, the Solomon Islands have experienced an average rise by about 7 to 10 millimeters per year since 1994. The research team, who published their study in the journal Environmental Research Letters on Friday, discovered that the sea level rise has destroyed villages that have existed since the 1930s and has displaced numerous communities. Increasingly violent typhoons to hit China and Southeast Asia. New research shows typhoons in East and Southeast Asia are becoming stronger and look set to continue to intensify. Ocean waters in East and Southeast Asia have become significantly warmer. As typhoons pass over warm water, they absorb some of the thermal energy and become stronger. Research reveals that typhoons in the region have become up to 15% more powerful over the past 4 decades. Typhoon Lion Rock swept across northern Japan on the night of September 6th. It has already killed 17 people, and the country is...
Antarctica is melting faster than anyone thought, and we are not ready for the sea level rise that's coming. Kevin Luria predicts crevasses near the grounding line of Pine Island Glacier, Antarctica. Near the grounding line of Pine Island Glacier, Antarctica. Ian Jugan, University of Washington. Ice melting rates in Antarctica tripped between 2012 and 2017, according to a study published in the journal Nature. The global study predicts the biggest increase has been ice melt in West Antarctica, where glaciers and ice sheets are vulnerable to warmer ocean temperatures. Experts think that if we don't get climate change under control quickly, ice sheets in West Antarctica could collapse, leading to rapid sea level rise around the globe. In the future, seas will rise far higher than they are today. The question is whether it happens quickly or slowly. There's enough ice stacked on top of Antarctica to rise seas around the globe by almost 200 feet. While it takes time for major changes to occur with that much ice, Antarctica is melting faster than we thought, according to a study recently published in the journal Nature. The melting rate has been spreading up significantly in recent years. Between 1999 and 2017, Antarctica lost more than 3.3 trillion tons of ice, causing sea levels around the globe to rise an average of 8 millimeters. About 40% of that loss occurred between 2012 and 2017. According to the new study from 1992 to 2012, the continent lost about 84 billion tons of ice a year, and over the next 5 years, that jumped to more than 240 billion tons per year. If the acceleration of ice melt were to continue, it could potentially cascade, leading to runaway ice melt and rapid sea level rise. The biggest change have come on West Antarctica, where the glaciers holding back ice sheets rest and rapidly warming ocean waters, causing them to melt more quickly. Climate science professor Chis Rapelye of the University College of London has previously described Antarctica as a slumbering giant of ice melt and sea level rise that seems to be awakening. A British Antarctic survey, two-man field camp next to the obelisk on Alexander Island, Antarctic Peninsula, Hamish Pritchard BAS says melting ice, rising seas. For the new study, scientists from 44 international organizations combined data from 24 different satellite surveys. Thanks to the satellites our space agencies have launched, we can now track polar ice sheet, ice losses, and global sea levels contribution with confidence, said Andrew Shepard of the University of Leeds, who led the study along with Eric Evans and NASA's JPL laboratory. The continent is causing sea levels to rise faster today than at any time in the past. The research brings our understanding of the current state of Antarctica ice up to date. According to researchers not involved in the study, while 8 millimeters of sea level rise from Antarctica melting alone might not sound extreme, the rapid changes associated with it should be enough to give anyone pause. In the 20th century, sea levels around the globe rise about 6 inches on average. The loss of ice on one side of the world tends to make seas rise on the other side due to gravity. As mass from Antarctic ice sheet is lost, gravity in that region decreases, which means that places farthest from that ice sheet tend to see the biggest increases in sea level. Right now, 3 factors contribute about equally to global sea level rise, according to Oppenheimer. First, as the world has warmed as a result of the burning of fossil fuels, oceans have absorbed the majority of the heat. Warmer water expands, which takes up more space. Second, glaciers are melting, adding more water to the system. The third factor is the ice sheets in Antarctica and Greenland that are still protected by glaciers. Antarctica iceberg A68 center drifts off the Antarctic Peninsula in this daytime satellite image.
Render the Larsen C ice shelf unstable and cause it to disintegrate, like Larsen's A and B before it. New study reveals cause of glacier melt in Greenland. During the summer of 2015, Greenland experienced its highest rate of glacier melt ever recorded. A study shows the record high melt is linked to the effects of a phenomenon known as Arctic amplification. Arctic amplification refers to the faster warming of the Arctic compared to the rest of the northern hemisphere as sea ice disappears. It is fueled by a feedback loop. Rising global temperatures are melting Arctic sea ice, leaving dark open water that absorbs more solar radiation, further warming the Arctic. According to the study, the atmosphere and the oceans combined are contributing to the melting of vast ice sheets off the coast of northern Greenland. The effects of Arctic amplification are unknown, but scientists believe it can change the Arctic jet stream flow, which circles the northern latitudes. Jet streams are narrow bands of strong winds in the upper atmosphere that follow the boundaries of hot and cold air. In the Arctic's case, frigid polar air is separated from warmer air in the south. A slowdown in the jet stream would cause wilder swings and allow it to bend farther north than usual, creating a high-pressure system called a cutoff high. The cutoff high draws in warm air from lower latitudes, leading to greater ice melt conditions. The study found that during the warmest summer in Greenland, the jet stream reached latitudes never before recorded during that time of year. The Arctic amplification is now cited as the cause for the melting of Greenland's ice sheet, which is the Earth's second largest after Antarctica. The ice sheet holds enough ice that if it were to melt entirely, it would raise the average global sea level by about 7 meters and lead to ocean warming worldwide. Watermelon snow is melting Arctic glaciers. A recent study published by scientists in Europe found that algae within Arctic snow is making Arctic glaciers melt faster. Watermelon snow is triggered by a type of green algae known as Chlamydomonas nivalis, which lies dormant during the winter under piles of snow. When temperatures rise above freezing in the spring, the surface melts and the meltwater brings nutrients to the dormant algae cells, stimulating germination. The cells then release green swimming cells with 2 flagella to propel them to the surface of the snow and daylight. In order to protect themselves from the increased UV light, the algae produce a red carotenoid pigment that changes their colors to pink and red. Ice and snow have a high reflectivity, or albedo, but the red algae darkens the snow and causes it to absorb more sunlight, reducing the albedo of snow by as much as 13%. The melted snow leads to the algae growth, which darkens the snow and causes more to melt, which in turn triggers an algal bloom. Scientists estimate that at least 50% of the snow surface in the Arctic will be covered by algal bloom during the summer. In addition to the Arctic, watermelon snow can also be found in places including Antarctica, the Himalayas, and the Rocky Mountains. More worrying news from Antarctica. NASA reports that an iceberg about the size of Delaware split off from Antarctica's Larsen Sea ice shelf between July 10th and July 12th. Scientists warn that the breakoff could trigger new ice cracks and cause even more icebergs to separate from the shelf. Ice shelves are the floating parts of glaciers that act as a support mechanism. In a stable glacier ice shelf system, the glacier's downhill movement is offset by the buoyant force of the water at the ice shelf front. The system is destabilized when warmer temperatures melt both the surface and underside of the ice shelves, and this eventually leads to calving. However, collapsed ice
Or when glaciers holding those ice sheets back collapse, ice sheets are expected to become by far the biggest cause of sea level rise. And one of the most vulnerable ice sheets is that one of the West Antarctica, where melting rate has increased most quickly. Time is running out, and an article published alongside the Blue Research, a team of researchers, described 2 possible scenarios for near future. Within a short period of time, we will have either taken action to drastically reduce greenhouse gas emissions and climate change, or we won't. If we dramatically cut emissions and keep global temperatures from climbing more than 2 degrees Celsius by the end of the century, we are far more likely to avoid rapid ice sheet collapse according to the study. We are already baked a certain amount of sea level rise into the planet system. Global temperatures are close to what they were about 1,25,000 years ago, when seas were 20 to 30 feet higher than they are now, according to Antarctica, a geologist at the University of Florida who spoke at the same sea level rise briefing. That means the planet will see at least that much sea level rise eventually through it.